Question uses the rectangle and then the semicircle or the half circle. It tells us that we know the center of the circle is found at O and that the diameter is P to Q of the circle, which tells us that if this is the diameter, then it's a half circle or a semicircle. There's a rectangle inside, and we always just read the question to check if there's any additional question or information that we might need to add to our drawing that wasn't already there. So we need to find the length of the arc BQ. So what that means is we need to find the length of this part of the line. The arc is like the circumference on a circle of a circle that's not complete. So any sort of sector where we're only looking at a certain angle. So if that's the arc I'm looking for, then essentially I could join these up and create the edge of the sector. So essentially this is the kind of shape that I'm looking at. I could ignore everything else and just look at that kind of blue and yellow part of the shape. Now obviously I need to find first of all the radius, because anytime that I'm finding the arc length, I'm using the formula of theta over 360, which is the angle of the circle that I'm interested in. And I'm going to times that by 2 pi times the radius, or 2 pi r. And that's the normal formula for the circumference of a circle, but we multiply it by the fraction of the circle we have, which is the number of degrees out of 360, the full circle. And that's actually in your formula book. So we can't do anything extra until we know that angle and until we know the circumference. So we need to work out those two things first. So one thing that we could do straight away, if we look at this circle, I'm actually just going to zoom in on the rectangle part of it. If this measurement here is 5, that means that the measurement from B to C is also 5, and by the same reasoning, this is 8. I'm now going to just look at this triangle here. And this is a right-angled triangle. Using my SOHCAHTOA, or right-angled triangle knowledge, this is my hypotenuse. And if I use this as my angle, let's call it X, this is my opposite and my adjacent. That means that I currently have the opposite and the adjacent, and I'm trying to find the angle. And to do that, I can use tan. So tan of the angle, X, is equal to the opposite over the adjacent. That's using my SOHCAHTOA, TOA, tan equals opposite over adjacent. So if I use my calculator now, I can use the numeric solve and I can find what my angle is equal to. So tan of X, and I have here the fraction, so I'm just going to type it in as a fraction of 5/8. And if I solve that, I can see that my angle is 31.97, which is to 3 significant figures, 32.0. So I have 32.0 degrees. That means that I've now found the degrees of the full circle that I wanted to use for my area, because this angle here is going to be 180 minus the X, which is this part here. So it's 180 for the full circle minus the X. So that means that I can now find that theta is equal to 180 minus 32. And you can just use your calculator to work that out. 180 minus 32 is 148. So I now know that my formula is 148 over 360 times 2 pi, and I still need to work out what is my measurement for R. But if I go back to that same triangle, what I could do now, if I know that my angle here is 32.0, then I could use my SOHCAHTOA to find the hypotenuse. Or Because I can still do that method, but I'm using a rounded answer with my angle. So an even better method would be to use Pythagoras, because then it uses the information that I've been given and I don't need that angle. So using Pythagoras, I would have a squared plus b squared equals c squared. My c always has to be the hypotenuse or the longer side. So 5 squared plus 8 squared equals the hypotenuse squared. And I'm now going to try to work out what that would be. So again, we could just use numeric solve. And you have 5 squared plus 8 squared. And in the one below, that is equal to x squared. And again, I can solve that. And I find that I have 9.43 to 3 significant figures. So 9.43 is the length of my hypotenuse, and it's also my radius. So it's the radius of the circle. It must also be that measurement there. Now that I have all the information that I need in my formula, I can work out the arc length. And again, I can just use my calculator to do that. So I have 148 over 360, and I'm going to multiply that by 2 times, and then I have pi. So to do pi, it's second function and this up arrow, and times 9.43. And I can see that my arc length is then 24.4 to 3 significant figures. Now it doesn't have any units on here. There's no centimeters or meters mentioned. So that means that my answer would just be left as 24.4. And for the method marks here, you would have 1 for using the tan formula correctly, and for finding the answer of 32 for the angle, or you may have found the 148 for the other side. Either of those things would be fine. So, so you can have found either this part or this part. Either is fine there. And then there is also 1 mark, for using Pythagoras and for finding the radius, so the 9.43, so this is 1 mark. And then there's 1 mark for using this arc length formula and 1 mark for the final answer. So that would then show you exactly where all of those marks are given.